And I'm just going to record this also on the cloud so that we have it there. So, shall we? Parametric collective. Oops.
I turned that off. It's
Yeah,
me.
we're live. We are live. Say hi to the world.
Hello, world.
Hello, down YouTube.
Hello, YouTube, and we are live. So, like, let's hear it from Parametric Collective.
Yeah, we've started. We've continued with the extraction of the data that we want to, and yeah, Michael has some progress on his screen. I don't know if I can.
Shall I try and share it? Yeah. Okay. Share. So we've managed to sort out our problem earlier where we couldn't really search for specific parts of the database because it was all split up like this. So we've just included this Python module now provided by Nareed, which now allows us to search for more specific things. So like, where are we? Yeah, with our building footprints, we now know that all of these are our buildings, and then we can associate their tags to them afterwards, which should allow us to hunt for the building use, and then you know, find out where we are after that. Yeah, so it's sorted that problem out. It allows us to move forward a bit better. Sorry, I'll stop sharing a minute. If you want to go talk about the DQN, maybe.
And Zvonko has some progress on the DQN. We have an agent working into a new environment.
I didn't see Zvonko in this call actually.
Yes.
Am I blind?
Here,
hello. Hello.
I'm tweeting with. Is he walking? Yeah, he's walking around.
Are you able to share your screen?
Yeah.
Is he walking? I like how he's already a person.
I think it was gendered pretty early on as well.
Yeah, like maybe I prefer if it's a she, but anyway.
Nice.
Nice.
Oh, this is our plots. These are our buildings or plots or whatever you want to call them.
Mm-hmm.
So, and now he's searching for the best plot, or just walking around inspecting all the plots according to these values. Like, I think I put in length, length and number of buildings right now. I mean, it can be, I want to expand it with a lot more parameters, and we'll probably want to do it with the area and the price and the distance from certain OSM things, because right now this is kind of a boxed playground model.
Yeah.
And I need to get in the OSM data from Mike, and so we would have some actual real world data and playground. And
Zvonko, do me a favor and click the distance between the center point and all the buildings there, so you can better visualize what the agent is actually seeing. It's slightly
what is the green lines?
Yeah,
because
so
it
that's
looks
slightly
like half
misleading.
of the.
So that there is nothing. It's just where it is. So Zvonko, if you can go down slightly.
It does look like the logo of one of the major political parties in Greece, by the way, PASOK. So the Greeks here will get the joke, but anyway.
And then just click the start endpoint line to the left.
It doesn't exist anymore.
Of course, it does exist. It always exists. It never.
Oh, some political statements
let's
here.
not start.
We are live on YouTube.
Yeah, this is what.
Exactly. Okay, that's better. Yeah.
Nice. Okay.
So that's like to the points of interest, it measures the distance.
Yeah. Right now it's just to these buildings, and it's keeping away from this park. Like, there is a park,
which is currently just a placeholder.
Yeah, currently it's just a placeholder. Maybe it's some bad place, whatever. He needs to stay away from this part in this case.
And now it has like a global perception of everything, of the whole area it's gonna check out.
Yeah.
It doesn't stop anywhere. Like, so like, I'm a bit confused, like, anyway, yeah.
Right now, I haven't really set the weight and reward schemes quite well because it's still running on Merit's reward scheme. Right.
Okay, okay. That's why we were just kind of like moving a little bit randomly rather than.
Yeah.
But also reinforcement learning takes ages.
Ages,
so.
yeah, yeah. Yesterday I ran your model for 2000 iteration. It was really, really dumb at the end. He kept crashing into the first wall. So.
Can confirm.
But you said there are like ways when you have a different course and training data.
Question, please.
Okay.
Yeah. So may I stop sharing?
Yeah, sure.
Yeah.
Cool.
Good job, guys.
Oops, it's cool.
Well done.
Thanks.
You're very close. You're very close. Next one. Who's next? Kim? No. This is. Wait, this is Kinbeans. Yeah, Kinbeans.
Okay. So we managed to run this machine learning code thanks to Yosha, and now we have something like this going on. So we have an input image representing some buildings and well, screenshot from Raina, and it's colored with the real images from street views. But the training database is really small, so the result is not so bright and good as it could be. So now we will retrain the model and improve it.
Can I ask, how many iterations did you train this one for?
It was trained for 50 iterations, but only with one image.
Right, understood.
Wow.
Yeah, we had to get the workflow working. So this
Okay. Yeah, and it's gonna learn one thing. All right.
Well done.
But one question there to the Mask RCNN, can you run all the images, let's say 2000 Street View images through it in one batch, right? It's probably quite straightforward.
In a batch? I'm not sure what you mean by batch, but yeah, you can do one after the other. Yeah.
Yeah, that's batch.
No, but like when you talk machine learning algorithms, you can stack them together. Okay, yeah, it doesn't matter. Yes, you can do that. Is that something you guys are interested in doing?
Yeah,
I could imagine it would be interesting for them.
Yeah, it would be great if we can like get more data. Actually, we are trying to streamline the whole acquisition process of information, because right now we have like many different pieces for getting the images, plugging them into the components of Grasshopper, then training the whole thing. So if you have any suggestion about how to get more images, that's great. As well, Theodoros was suggesting us to do like some documentation for expanding the possibilities of the images. So yeah, any suggestion on that sense, it's great.
Yeah.
Documentation.
Yeah, for most teams it will help, because most teams are operating at a very, let's say, low data availability and not a lot of time. So augmentation is a nice way of, let's say, helping with that problem.
In terms of getting more data, I wasn't entirely sure of what you're referring to. Is it getting more data from Mapillary? And you're interested in like a better way to do so, or?
I mean, it can be both actually. I mean, it can be like doing that segmentation with the data that we already have, and like doing crops or even doing rotations or whatever, or a small like deformation shift. But as well, I mean, we can get like just more images in an automatic way without needing to describe it manually. It's as well.
Sure. As it stands, the Mapillary workflow should be a pretty automated way of getting a lot of discrete view images in terms of running mask RCNN over a batch of images. You can just do a for loop, and then I'll actually write a snippet for you right now, and then show you how to stack that on top of each other. Actually, I'll do it after the session, but it's very easy.
Cool.
Very cool. Thank you.
Sounds great. Who's next?
Cool. Yeah. Next is spatials. Spatials.
Hello.
Who's going to start?
Yeah. So this spatial analysis, is that the same?
Yeah. Sorry. Spatials. I don't know.
Okay.
Should be spatials.
So I'm gonna share my screen.
Yeah, sure. Go ahead.
So I think what we were focusing on is just getting the training to work. So with the help of Yosha, I got this to work, and this is just an input of the images that the algorithm has already seen, but just trying to find out a way to test out with new images. I just plug this into something that allows Paint to kind of interact with it. So if I say draw,
it's always beautiful to see Paint.
Yeah.
It's always beautiful.
Man, can you imagine if this was a live connection between Paint?
That would be awesome.
Where's the image?
No, it's somewhere.
Paint is beautiful.
Actually, we are once participated in the hackathon and had to make a live connection between Paint and Grasshopper.
I know.
It was one of them.
So stupid.
I think one way could be just to pick the last modified file, and then just it wouldn't more or less work next to each other. But the problem we have now is the way we gave it the information, and also the amount of training data that we had. So all it wants to do now is color all of our buildings gray, and regardless of how the information changes. But I think Theodore's mentioned that we should maybe make the information more diverse by rotating it or changing the location of the target, and probably have better results.
Also, I thought about maybe in the input images not coloring the buildings white, because white or any shade of gray is also a part of the work the computer has to do. So maybe a different color would not bias it in a way. Does that make any sense?
I'm not sure. I mean, I think it can have an impact on the results, the color schemes to a degree. But what do you know?
Definitely try. Just definitely try it, I guess, and see. It could be like very low information right now. Maybe it will help.
Maybe a 50% shade of gray, because then it would understand that it is supposed to go either clearer or darker, and not just any sort of darker, you know.
Yeah, you can try that. It sounds interesting.
Yeah. Okay.
And of course, make sure that you set the scales, perhaps manually, not that you do use this renumber things, whatever you look at, but that's like a global reference number for what is 50 meters high, what is 10 meters high. Just like a little reminder that there's one scale across all images that are created.
We did try a little bit different color schemes with Theodore in the past. I think Theodore, I think they made minimal impact, right?
Yeah.
Yeah, I think yeah. In terms of training, you can try. You never know, but normally it's not the biggest issue. But it's an interesting idea to go from the middle up or down. So it might learn direction.
Yeah.
Anyway,
Cool.
it seems good.
On the way.
Well on the way, yeah. So,
What's next?
thank you. Let's move on. Microclimate.
Yeah, so basically we are still preparing the, the training data. We have generated, we've taken the aerial photo. I can share my screen if it. It's processing in the background, so it might not be too responsive, but.
Slightly more advanced than the previous group because it's using Photoshop rather than.
Yeah. So actually, so we took this aerial photo and yeah, and colored the green spaces, which should show up in the next second. Yeah, exactly. And then we exported all those little tiles, and we did also rotation, so it gives us in the end, like those are the photos, and then we have this colored, so marked green areas here. And this would now be the input into our model to train, and see then if the model is able then to spot green areas, and so we can detect like density for each tile of green space. And that's the first step, and then we could go on and do the same stuff for like shadow areas to estimate building heights and see maybe patterns, which we haven't thought before. New stuff.
Yeah.
Work in progress.
Yeah, the methodology is also very interesting.
Yeah, maybe. Yeah. Leah, if you want to present the methodology on a high level.
Sure. Okay, so our problem we are tackling is to find location in Vienna where we can tackle the microclimate. And this is by locating where we have the highest density, the lowest greenery areas, and where we have less sky view factor. So how we are doing this is by first taking satellite images, and with those satellite images we're gonna use pix-to-pix models to analyze how much green area we have, how much house density we have, and from the same location we are using for the satellite to take street views, and from those street views to analyze how much sky view factor we have. So at the end, we can analyze in the city where we want to tackle the microclimate. So this is mainly the big idea, and now we are doing the greenery thing with the data Edward just showed.
Great overview there.
Great. Yeah, that will be helpful for Friday as well.
Cool. Great.
All right. So last team is Scale Squad 2. By the way,
updated.
By the way, you're presenting on Friday. If you want to change your name, you're welcome to do so. We did give you
maybe Scale Squad 3.
Wait. Yeah, if you want to make it a little bit better, Scale Squad 3 makes more sense, or 4. But anyway, like you don't have to stick with these names. They were ridiculous. They were ridiculous on purpose so that you can change them. But it seems that you really like them. So like Scale Squad 2 it is for now, and spatials, whatever. You just give your own name to your groups. It doesn't matter.
I think the name is fine for now.
Yes.
It's the results, not the name, really.
Not the #1 concern. Fair enough.
not the biggest problem.
So we adjusted the workflow a little bit during the break, and Christine also went through the grasshopper definition. What we will focus now, we figured that the shadow thing might be a little bit complex to handle right now within this very limited time. So what we will go for is the topology. So maybe the model will be trained to identify or to make a correlation between different topologies and different heights. So we will use the model that is already available with the Rhino that you give us, the Rhino model, and we will try to generate different topologies, make height map. So we'll have basically the input as two maps, the footprint and the height map, and then we'll train the model based on that. Christina can share a little bit about the grasshopper definition, where we finally arrived.
I'm afraid you are muted right now, Christina.
Can you unmute her?
You can just
suggest. I just asked you to unmute
Can you
yourself.
hear me? I have
Yes.
Because I have a problem with my laptops.
So you have two accounts. Yeah, I see that. Because you like talk. I see you there. You're talking
okay. Okay,
So,
you're muted, but you still can talk.
I can talk from one of the laptops, but in general it has crashed, so I cannot show anything. I mean, Rhino is not working, the camera is not working. So here I don't have Rhino, so I'm sorry. But what we are going to do is we can use the workflow from the previous theme. Is the upper part of the previous theme. We are going to the Vienna playground, and as it was said, we are just going to put these two inputs and see what kind of results we're gonna have. But we are, with your help, we are at a quite good shape, I think.
Great.
Very good.
Good.
Thank you.
Yeah. That was all groups, right?
Yeah.
That was it. Nice.
I think so. So, okay, so we're presenting on Friday the final result of this, but we do have one more day. Like we have today as much as you want, and like tomorrow we'll be there constantly to help, and we'd be happy to just like jump on a meeting if need be to solve out something, according to our schedules as well. But if you guys want to, like, please use Slack for that, and we will be able to help. So before I turn off the YouTube live kind of like channel, we will present on Friday, 12 CET, at like noon CET, like Central European Time, and we will have invited some people there to see us. So to the rest of the world, see you, well, whatever is watching, random bots watching on YouTube. See you on Friday, and well, I'm gonna turn off the live stream now. Bye bye.